Lesson 7-3, multiplying polynomials on page 408 I'm going to skip what's called the FOIL method, because if you use the distributive property method, you'll get the same answers. So I'm going to stick with the distributive property in this video and go from there. So let's go ahead and start on the guided practice. When we're multiplying a binomial and a binomial, if you're using the distributive property, it doesn't matter actually how many terms you're multiplying by. For the FOIL method, you can only use a binomial and a binomial. But since we're doing distributive, it doesn't matter if I have 2 terms or 3 terms or 4 or however many. I'm using the distributive property. So what I have here is, like I said, a binomial. This is a term, 3m, and a positive 4 is my second term in the first binomial. And another binomial, m plus 5. This one is m and a positive 5 as the 2 terms. Remember when we did adding and subtracting? Between the 2 parentheses, there was a plus or there was a minus. If there was a plus here, then we added. If there was a minus, then we subtracted. Because there's nothing between the 2 parentheses, we know that this is multiplying parentheses, or multiplying polynomials. So also it says find each product, and product means multiplication, if we remember from back with linear equations. Okay, so let's start. Normally, if we were to just have a 4 outside of a set of parentheses, we would multiply that 4 by the m, and we would multiply that 4 by the 5. So it's the same process here, except there's 2 things outside the parentheses. So we're going to multiply the m and the 5 by both terms in the first set. So first I'm going to do the 3m times m. 3m multiplied by m is 3m squared. Then I'm going to do 3m times the second term. 3m times 5 gives me 15m. After that, I have to multiply both of these by the 4. So I have 4 multiplied by m, positive 4m, and 4 multiplied by 5, positive 20. Okay, now unlike the adding and subtracting, unlike the multiplying a monomial by a polynomial, here I have some distributive property. After I distributed, I have some combining like terms that I can do, because this 15m is a like term with the 4m. So if I add 15m and 4m, I'm going to get 19m. The 3m squared and the 20 don't have any like terms, so I'm going to put them at the beginning and the end. Remember that since this is a positive 19, I put a plus sign. Okay, so my final answer here after I multiplied is 3m squared plus 19m plus 20. And that's the product of a binomial times a binomial. Look, notice it's a trinomial. Most of the time, if you do binomial and binomial, you're gonna get a trinomial. Okay, here, same thing. 5y multiplied by y. 5y multiplied by 8. Then I have negative 2y multiplied by y. I'm sorry, negative 2 multiplied by y. And negative 2 multiplied by 8. So this will give me negative 16 at the end. Usually the middle 2 are the ones that will combine. So we're going to combine positive 40 and negative 2. So 40 minus 2 gives me 38. Or 40 plus negative 2 gives me 38y. Do not change the exponents when you're combining like terms. If you're multiplying a letter by a letter, a variable by a variable, then you would change exponents. If you're adding, you don't change the exponents. You leave it a y. Okay, and then the negative 16 and the 5y squared don't have any like terms. So this is my final answer on this one as well. Okay, a quadratic expression is one of the vocabulary words in this section. A quadratic expression is just any expression that has one type of variable. So see, these are all y's, these are all m's, with a degree of 2. So this has a degree of 2, The whole polynomial, the highest degree is 2, so the whole polynomial has a degree of 2. Okay, and normally if you're doing a linear by a linear, so a degree of 1 by a degree of 1, you're going to get, actually always, you're going to get a degree of 2, which is called a quadratic. So if it has a degree of 2 for the polynomial, it's called a quadratic expression. Okay, let's look at the pool example because a lot of you were having trouble with word problems in class. So I want to explain some. I know it's difficult kind of to break through all of these words. So this says, a contractor is building a deck around a rectangular swimming pool. The deck is X meters from every side of the pool. Write in an expression for the total area. Remember, area is length multiplied by width of the pool and deck. Okay, so they even drew us a little picture here. So what we have is this walkway, the brown, and the swimming pool, which is the blue. And so they have said they want to know the whole thing, not just the area of the swimming pool, but the area of the whole thing. And so we need to figure out how long the brown sides are total. Now we know the blue side, let's work on just this side, or this side. The blue part is 20, but we know there's an X brown part here, and it says it's X all around, X meters from every side. So that means the other side will also be X. So this total length is X plus the X plus the 20. So it's this X over here plus this X over here plus the 20 from the pool. So this is going to give us 2x plus 20, 2x plus 20 for our length of the pool. The width is the same process. So here we've got 15 for the pool, and it's still x and x. So x plus x is 2x plus the 20. So my, 15. 15 is this side length. So my expression for width is 2x plus 15. So if I want to find the area, I need to multiply them together. And so they multiplied 2x and got 4x squared, 2x and 15, 30x, then 20 and 2, 40x, 20 and 15 is 300. Combine, and their final answer was 4x squared plus 70x plus 300 for the total area of the deck. Okay, and then in this one it says if the pool is 25 meters long and 20 meters wide, find the area. So it's the same process, except instead of 20, this would be 25, and instead of 15, this one would be 20. So they just changed the numbers here, and so they would change the 20 and the 15 there. Okay, moving on to this bottom part, these are binomials times trinomials. So when you're multiplying a binomial and a trinomial, the process is the same, it's just a little longer because you're multiplying by 3 terms instead of just 2. So first we're going to multiply the 3x by each term in the trinomial. So 3x multiplied by 2x squared would give me 6x to the 3rd power. Remember, I'm adding exponents if I am multiplying like bases. So multiplying like the bases, we add the exponents. So I have 6x to the 3rd here, and then 3x multiplied by 7x is a positive 21x squared. So here again, we have 1x here and 1x here, so 2 x's. Last part, 3x minus 8 would give me negative 24x for that part. Okay, so we're half done. We did the 3x, now we have to do the negative 5. So I'm going to do negative 5 times 2x squared is negative 10x squared. Negative 5 times 7x is negative 35x. And negative 5 times negative 8 is positive 40. Okay, so this is my long polynomial, and I'll probably be able to combine some things. So here's a squared, and here's a squared. here's an x, and here's an x. Okay, so I have 6x cubed. It doesn't have any like terms, so I'm going to keep it at the front, and I don't need to add or subtract anything from that one. And then I have, with the x's, I have a positive 21 and a negative 10. So I'm going to do 21 minus 10 and get 11 x squared. So I've used this one and this one and this one. Now I have negative 24 and negative 35, which would give me negative 59. And then the positive 40 at the end. There's no more like terms, and it's in standard form and all of that, so we're good. Okay, this last one is a trinomial and a trinomial, so it's even going to be longer than the previous one. So here we've got m squared multiplied by 4m squared, 4m to the fourth, minus 7m to the third, plus 5m squared. Then I'm going to do the 2m. Let's do that one in a different color so we can see it a little bit better. 2m multiplied by 4m squared is going to give me 8m cubed. 2m and negative 7m is negative 14m squared. And then 2m and 5 is a positive 10m. Okay, and then I have one more set. The negative 3 multiplied by 4m squared gives me negative 12m squared. Negative 3 times negative 7 is a positive 21m. And negative 3 times 5 is negative 15. So here again, I need to combine my like terms. So let's find some like terms. The 4m to the fourth power has no like terms, so I'm just going to go ahead and write it. 4m to the fourth, because it's my biggest exponent, so it's going to go first. The cubed has one there, and then it has another one here. So we have negative 7 and positive 8, which would give me a positive 1m to the third. Then I have 3 that say squared, so I have a negative 5m squared, and a negative 14m squared, and a negative 12m squared. They're all negative, so I need to keep that in mind. So I'm going to get negative 31 when I add them all together. I have 2 m's, 21 and 10 add to give me 31m, and then the negative 15 gets put on the end also. So this is my final answer for that one. That's it.